I wanted to demonstrate too that you can actually generate a high voltage with a tank circuit. Again, it's a matter of the impedance. See, I'm still using the same resistor, voltage, and inductance as my other video showed. But let me kind of reset it and show you what happens. But I used a 100 nanofarad capacitor on it instead, and so like I said, you're, let's see, dealing with, I feel like copying this actually. I'm going to leave it available for my notes. But let's change the reactance, to the 10 millihenries that I have it, and then I put this at 100 nanofarads rather. Okay, so that gives us about 5 kilohertz for the frequency, and its reactance, is 316 ohms at that resonant frequency, for each component. So, but, which is what I have here. I have this diagram, but the difference is that we are still going to be putting 10 amps through this inductor, and I'll show you what I mean. Let me close the switch. Okay, so you see some initial oscillations, but they start to die off. But eventually this will, reach a stable state like it did in the other. Let me speed it up here. Okay, so the voltage is 0 now. That's 0 volts, but we've got 10 amps of current, which is flowing through the inductor, as you see, and nothing flowing through the capacitor. 0 volts in the system. Okay, but now I'm going to open up that switch, and there's what starts to happen right there. So, but basically you can see that's 3 kilovolts of voltage. It's being formed there. So that's because you got 10 amps flowing through the 300 ohms that you see in PTC MathCAD here, the free version. So you got 316 ohms times 10 amps, that's 3100 volts. So it shows that even an LC tank circuit can generate, just like a series circuit can. It can generate high voltages too. It's a question of, do you have a high enough impedance? Because these are all practical values. I mean, 100 nanofarad, yeah, you can certainly make that, and 10 millihenry, if you have a good strong coil, and to put in series with a 1 ohm resistor and a 10 volt supply, you can do this and it'll generate, a waveform just like this. Now, of course, change this to like 100K or something. Well, let me change it to 10K. Of course, sticking a resistor in there, you'll see that it'll actually start decaying if I put a dampener in it, and that's kind of how a real circuit would be. Because you're probably going to have some load resistance like that, but it's like I said, it's got like 3 kilovolts with a 10K resistor on it, so it's going to generate, a healthy but not severe current, but it'll decay from 3 kilovolts down to eventually 0, if I run this long enough. Oops. So, you can see, the voltage is getting lower and lower and lower and lower. Because of that, and I'd have to, close the switch to kind of charge the thing back up a little bit. And I release the switch, and now we're, generating, about 100 volts, because I didn't leave the switch long enough for the inductor to charge up more than a few fractions of an amp. Let's see, I got it at like 2 amps or so, but then I open the switch, alright. 2 amps times 300 ohms, so that's going to be like, you know, like 600 volts or whatever, you know, is what it's going to be up to. So, you know, that's kind of how it works. So, I mean, you can generate high voltages with a tank circuit too. So, I've had the epiphany of this while I was sitting there thinking about the results. But, you know, you can see how this decays, and, you know, eventually, because a real circuit, you know, it's going to be kind of the same thing. You know, it's not going to take too long for, you know, for the thing to decay to zero. So it's a real temporary event, and, you know, if you wanted to keep this up, you need, you know, occasionally have like an electronic switch here with 10 volts hooked to it. And if you close the switch in exactly the right time, you know, particularly a zero crossing, and leave it closed, you know, for less than a quarter cycle, you know, you can actually keep this maintained if you wanted to make a practical circuit. But again, you better make sure your circuit components can withstand 3 kilovolts, like the capacitor or the inductor. You know, otherwise you're going to have a bad hair day.